Welcome, listeners, to another deep dive. Today, we're taking a bit of a shortcut, really, to getting you well informed about the very latest from Google Cloud Platform. We've just sifted through the key updates from August 1st to 15th, 2025, and we're here to pull out the important stuff, those aha moments, so you feel caught up without feeling overwhelmed. Think of it as your quick briefing on what's really impactful right now in GCP.
Exactly. And these updates, they really show some significant forward-thinking moves across the whole Google Cloud ecosystem. Our focus today is squarely on what this all means for you. Maybe you're just starting out on GCP, doing your first few deployments, or maybe you're looking to really optimize what you've already got running. We'll zero in on the practical side, especially for beginner to intermediate users.
Okay, sounds good. Let's unpack this. The first big theme that really jumped out, Google's strong push into AI agents. It seems like they're accelerating here. We saw a new developer toolkit announced specifically for scaling A2A agents on the platform. Seems designed to make it easier for developers to build and manage these things. So what's actually in this toolkit? What makes the difference?
Well, the core of it, it's version 0.3 of the A2A protocol. And what's really impactful here is the introduction of gRPC support and security card signing. Plus, there's extended client-side support in the Python SDK. Now, for folks maybe not deep in the weeds, gRPC, that's Google's high-performance way for things to talk. Think of it like giving your AI agents super fast, efficient, and solid lines of communication, essential for complex real-time stuff. Before this, getting agents to interact securely could be, well, messy. Like different apps speaking different languages, lots of custom code, potential security issues.
Right, okay. And security card signing. That sounds important, like a layer of trust between these agents. What's that mean for a developer trying to build a secure multi-agent system on Google Cloud?
That's exactly it. Security card signing. It's like giving each agent a verifiable digital ID, a unique signature on every message. It makes sure that when agents talk, you know exactly who's talking and that the message wasn't messed with. Makes the whole system way more secure, trustworthy, auditable, which is critical when you're putting these things into production. And deployment-wise, the nice thing is developers get flexible options right within the GCP services they probably already know. Agent Engine, Cloud Run, Google Kubernetes Engine, GKE. So if you're using those, you're kind of ahead of the curve.
Ah, got it. So this toolkit isn't just about building, it's about making them really production-ready and secure on GCP. Makes sense. But it's not just dedicated agents, right? AI seems to be weaving into everyday developer workflows too, which I find, honestly, pretty exciting. Gemini Code Assist, for example, now integrated directly into GitHub workflows. And here's the really interesting part at no charge. Gemini gets automatically assigned as a reviewer on pull requests, providing summaries and automated reviews. That sounds like a massive time saver for review cycles.
Oh, it absolutely is. The potential impact here is huge, just in terms of efficiency.
Yes.
Think about the time saved, letting human reviewers focus on the bigger picture, right? The architecture, the complex logic. Not just catching syntax errors or simple stuff.
So you don't think it risks de-emphasizing that human touch in reviews?
Well, I see your point, but I'd argue it actually frees up reviewers for more complex architectural thinking. It augments the human capability, makes the whole process smarter, not, replaces it entirely. And we're seeing similar moves in Colab Enterprise Notebook. New features like the Data Science Agent, the DSA. That automates end-to-end data science tasks. There's also multi-cell code generation, easy visualization from simple prompts, even automated error explanation and fixing. For any data scientist using GCP, these are, well, they're potentially transformative for productivity.
Okay. So Google's definitely pushing hard on AI agents and embedding AI in workflows, but all that intelligence needs a solid foundation, right? A powerful, optimized place to run. Which brings us nicely to our next big theme, boosting performance and scalability, especially with GKE.
Yes, exactly. Shifting gears to the infrastructure side. Container image streaming in GKE, it's gotten some significant upgrades. This is a really big deal if you're running apps with large container images. Think AML model serving, big data stuff, even complex microservices. Traditionally, pulling those huge images, that can mean serious delays in getting your app started.
Yeah, if you've ever stared at a screen waiting for a massive AI model to load, you know exactly how frustrating that is. Costly, too. So what's the key improvement here? How are they tackling that startup lag?
A key bit is the new intelligent read-ahead capabilities. Imagine GKE is packing a lunchbox for your application. Instead of waiting for the app to ask, hey, I need an apple, It proactively packs the apple, maybe a banana, a sandwich too, because it knows based on past behavior, you'll probably want them soon. It just drastically cuts down that waiting time for image data during startup, which directly means, faster, more efficient apps on GCP. Saves time, saves compute costs.
That intelligent read ahead sounds like a definite win. Faster startups are always good. But sticking with GKE and scalability, what about the network underneath? I heard something about multi-subnet support for clusters finally arriving. That feels like it removes a pretty major limitation for bigger deployments.
It absolutely does. The preview of multi-subnet support for GKE clusters is out. It basically gets rid of those old single subnet limits. Lets GKE clusters span across different subnets in your VPC network. Connecting this to the bigger picture, it means much better horizontal scaling for your clusters, better network resource use, more flexibility overall in how you set up GKE, especially if you're on GKE version 1.30.3-GKE TAT1211 or the later. It really enables more complex distributed apps. It's a pretty foundational improvement, and it reinforces why Gartner named Google a leader again in the Container Management Magic Quadrant for 2025. Third year running, it sort of solidifies things.
Right.
Okay, shifting gears again. Something every GCP user, beginner, or expert really needs to be aware of: security. We picked up a crucial nugget about something called dangling bucket attacks. That sounds subtle, but potentially nasty. What exactly is a dangling bucket attack, and why should listeners be worried?
Yeah, this one's critical, and it's very real, but also preventable. Okay, so a dangling bucket attack happens when you delete a storage bucket. Could be Google Cloud Storage, could be S3, but references to that bucket's name still exist somewhere, maybe in your old code, mobile apps, public docs, whatever. An attacker can then just go and claim that exact same bucket name in their own project. And because your old code or links still point to that name, boom, the attacker hijacks your old address. They could surf malware, maybe try to steal data from users still hitting that old, now compromised bucket name.
Wow. Okay, that's sneaky and scary. So the immediate question is, how do you stop this? What should people be checking? It's really a vital reminder for everyone on Google Cloud. Check your best practices, prevent these dangling bucket takeovers. It boils down to diligent cleanup. When you delete a bucket, you must ensure all references to it, internal, external, everywhere, are also removed or updated. Think of it like moving house, right? You don't just stop using the old address. You tell everyone important your new one. It really highlights the need for thorough cleanup and configuration management. Simple step, but could save you serious headaches.
Definitely something to check. Okay, let's move on to the data side of things. Google's Data Cloud, their unified AI-native platform, seems to be fully embracing that agent shift we talked about earlier. Really leaning into the AI-first approach. Looks like it's focusing on three main areas: new specialized AI agents, an interconnected network for them, and a unified AI-native data foundation. What are some of the key new agents here that might make life easier for data folks on GCP?
Yeah, we're seeing agents built for specific data jobs. Key new ones include the data engineering agent that's in preview inside BigQuery. It's for automating complex data pipelines. Huge for streamlining ETL. Then there's the data science agent, also preview, in Colab Enterprise Notebook. That helps with more autonomous analytical workflows, less manual coding for routine stuff, and maybe the most exciting for business users, the conversational analytics agent with Code Interpreter, also preview. This lets you do advanced business analysis just using natural language. Imagine asking a question plain English and getting deep insights back, often with the code generated behind the scenes.
That conversational agent. Yeah, that sounds like a big step for non-technical users getting more from their data. But what about getting insights across the whole data cloud? I saw something about Looker integration.
Right. What really caught my eye there was the Looker MCP integration. Looker, for those maybe less familiar, is Google Cloud's BI platform. This new integration lets you ask natural language questions in AI clients like Gemini CLI or Claude Code and interact directly with Looker. It just makes getting insights across your entire Google Data Cloud much, much simpler. Makes data more accessible. And on the database side, Google Cloud's Spanner columnar engine. That's a new feature. Designed to unify online transaction processing OLTP and analytical query processing OLAP, all within a single Spanner database.
Okay, hold on. Spanner's already known for its global scale and consistency. Unifying OLTP and OLAP inside it. That sounds like a massive shift. What does that actually mean for performance? Is it a big deal?
It's potentially revolutionary, yeah. Especially for what we call mixed workloads. See, OLTP handles your live transactions, day-to-day stuff. OLAP is for complex analysis, looking at trends. Usually you needed separate databases, complex processes to move data between them. That meant delays, complexity. With Spanner's columnar engine, you can run analytical queries directly on your live operational data. Some early benchmarks are showing analytical queries boosted up to 200 times faster. It gets rid of needing duplicate data, separate systems, real-time analytics on live data without killing transaction speed. It really changes the game for data architecture on Spanner.
Wow, 200x, that's huge. Opens up all sorts of possibilities. And quickly, for Cloud SQL users, there's something called enhanced backups. What's enhanced about them?
Right, enhanced backups. It's a new service aimed at seriously boosting data protection for Cloud SQL. The key things are immutable and logically gapped backup vaults. Okay, immutable means the backups can't be changed accidentally or maliciously. They're locked. Logically gapped means they're stored separately from the source project, providing a buffer. This gives you a crucial defense against threats like accidental deletion, ransomware, maybe even insider stuff. It's a significant upgrade for keeping Cloud SQL data safe and resilient.
Got it. Okay, let's shift focus one last time to optimizing how you actually build and deploy things. Always a challenge for developers. Specifically, I've heard a common headache with AI apps is hosting the model artifacts effectively. Like baking models into container images makes deployments slow and chunky, but downloading them at startup causes big delays. What's the recommended best practice now for handling this on Google Cloud?
Yeah, you've hit a major pain point there. Baking models in. Every model update means rebuilding and redeploying the whole app image. Inefficient. Downloading at startup. Latency, especially for big models. The better way, the suggested best practice now for production MLOps on GCP, is to decouple your model from your application. Host the model artifacts in cloud storage, then access them efficiently from GKE or Cloud Run.
Okay, decoupling. How does that actually improve things day to day for deployment and scaling?
Well, decoupling gives you immense flexibility. You can update models without touching your application code. Faster iterations, smaller deployments. It also lets you use smart loading strategies, like only load the model when it's needed, or cache it cleverly across instances. This approach really optimizes loading, allows for much faster changes, more dynamic scaling of your AI models. Keeps your AI apps agile and performing well.
That makes a lot of sense for faster development cycles. And speaking of best practices for deployment, Google Cloud now has something called Cloud Setup right in the console. My understanding is it guides you through deployment steps, even gives you a Terraform script to automate it. How much of a relief is that for developers, especially those maybe worried about getting security or performance settings wrong?
Oh, it's a tremendous relief, particularly for, beginner to intermediate users who might not be deep experts in every single cloud setting. What's really good about Cloud Setup is it offers three options: proof of concept, production, and enhanced security. It tailors the setup to what you actually need, gives you pre-validated, secure, optimized configurations. You're not just getting a checklist, you're getting a pre-built foundation via Terraform script. It significantly simplifies adopting secure, optimized setups on GCP. Really lowers the barrier to getting complex things right from the start.
Fantastic. Taking the guesswork out is always good. And finally, just on the overall developer experience, Google Cloud is piloting using generative AI, Gemini specifically, to help keep documentation and code samples up to date. That feels like it tackles a really common frustration finding outdated resources.
It absolutely does. And the question that jumps out is, how can AI make your learning and development process even smoother? This initiative directly hits that pain point of finding stale docs or broken code samples. We've all been there. By using AI internally to automatically update and verify this stuff, Google Cloud is aiming for a much more, delightful developer experience. It's a neat example of using AI to improve the platform itself, which benefits everyone building on GCP.
So wrapping this all up, what does it mean for you, our listener? We've seen Google Cloud Platform really pushing innovation across the board, from empowering AI agents and seriously boosting GKE performance, to tightening security against tricky things like dangling buckets, and ultimately just trying to streamline the whole developer journey with smarter tools and better resources.
Yeah, each of these pieces, these nuggets, they really reinforce Google Cloud's commitment. They're providing a powerful, secure, and increasingly intelligent platform. It's all designed to help you build and run your solutions more efficiently. Doesn't matter if it's data analytics, complex AI, or modern apps. That clear focus on AI native capabilities and really enhancing the developer experience, that definitely stands out in these updates.
Okay, so for our final provocative thought for this deep dive, how might all these rapid advancements, especially this boom in AI agents and these simpler, smarter deployment tools, how might they fundamentally change your approach, your way of building and managing applications in the cloud over the next year? What's the one nugget from today that you're most keen to explore further on your own? How might you use it in your projects on Google Cloud Platform? We definitely encourage you to dive deeper into these topics.